Alright, so where we left off on Friday, we had this. Don't worry about this guy. This is next. We're not there yet. We had simple triangle. We had we had 100 newtons pulling this way. We had a pin joint here, so we had reaction force A in the y direction. We had a pin joint here, reaction force A in the x direction. We had a roller support here, so we had reaction force C in the y direction. Okay? And then we had solved for some of these things. We knew RCY was 173 newtons, right? We figured that out. And then we found out that RAY then was 173 newtons, but in the opposite direction, right? So this was really that. Okay? And then RAX, we discovered, was really that direction. Okay? Negative 100 newtons. So that was our reaction forces, our external forces. We figured all that out. And then we moved to internal forces. We were looking at just the members of this triangle. And towards the end of the period, we said, okay, so if I looked at just point A, and I said just at point A, what was acting in the x direction? And there was only two things acting in the x direction at point A. There was RAX going this way, and the force of AC going that way. That's the only two things acting in the x direction on this point. And we know that the sum of forces in the x direction must equal 0. So RAX plus FAC must equal 0. And we knew RAX was negative 100 plus FAC equals 0. So FAC, add 100 to both sides, is 100 newtons. And then, so right at the end of the period, I said, okay, so FAC is 100 newtons, which direction? Which direction is FAC going?
Right.
Okay, right now it's going to the right. And we know that because I guessed that it was going to the right, and my number was positive, so I was correct. Okay, so it's going to the right. And then I said, okay, but we need to say if that's in tension or compression. Okay? We need to say if it's in tension or compression. So whenever a force is moving away from a joint, it's like it's pulling away from it, it's in tension. Okay? So it's pulling away from that joint, that means it's in tension. Okay? So we're pulling away from A, it's in tension. But a single member cannot be in tension one place and in compression someplace else. That doesn't make any sense. If it were in tension here but in compression here, then it would be moving. Right? So it has to be in tension everywhere. It's in tension here, it's pulling this way, and it's in tension here, it's pulling this way. It's like pulling in towards itself. Okay? And so what I said then is that when we move over to point C, okay, now we're over at point C, what direction is FAC going? What direction is FAC going now? It's going in, right, away from the joint, or AKA the left. Okay? So FAC is going this way. And that's a little tricky, right? Because you're like, wait, it's the same force, it should be going the same direction. It's in tension, right? So they're pulling away from the joints. So that's FAC at point C. Okay? All right, now, what else is acting in the x direction at point C? It can't just be FAC. Because is FAC 0?
No.
No, it's not. We already figured out FAC. It's 100 newtons.
It's 100 newtons
So,
at the top.
So it can't,
Oh,
well, 100, that's not touching C.
Yeah.
It affects it indirectly for sure, but it's not physically touching C.
FBC.
FBC. Is FBC acting in the x direction?
No.
Yes and no.
It's a diagonal, right? So that means some of it is acting in the x direction. How would you express that? How would you say that some of it is acting in the x direction?
What happens?
What's the signal for it?
F, B, C in the x direction. Okay? FBC in the x direction. Which way is it going?
X.
I don't know, so I'm going to say it's going to the right. Right? We guess positive because I don't know.
Same.
What's acting in the y direction at point C?
FBCY.
Okay, so FBCY. Why am I drawing it up?
We're guessing.
We're guessing. I don't know, so I'm choosing positive, which is up. Okay. What else is acting in the y direction at point C? RCY, I heard.
That's up.
Okay. And that's up. Am I guessing on this one?
No, we know.
Yeah, this one we actually know. So that one's for sure. I know that. All right, looking at this free body diagram, does it look balanced?
No.
No. So one of my guesses is wrong.
I mean,
Okay.
well, we only have one guess.
Yeah. So the guess that I have for the y direction is going to be wrong. That's okay. I know it's going to happen. So sum of forces in the x direction have to equal 0. It's the same game we keep playing. So negative FAC. Why is it negative?
Because it's going to the left.
On the left, okay. Plus FBCX equals 0. And this was negative 100. Plus FBCX 0. So FBCX then is 100. So what is that? Okay, so that's this diagonal right here. I'm going to kind of bring it out here. F, B, C, X. So that guy is 100 units. Okay? Well, now what? I could do the y's and solve for FBCY. That's not really all that big a deal. But I don't actually want FBCY necessarily. What am I trying to solve for? FBC is really what I'm after. So there's like 3 or 4 different ways I could do that. Right? I could solve for FBCY, which would basically be the opposite of this, right? So it would be negative 173 newtons, right?
Yeah.
So this is 173. Okay? I could use Pythagorean there, because I have 2 of the 3. I have these 2. I could solve for that one. I could do that. I could use trig functions, so I wouldn't even have to get FBCY. Right? What is this angle?
30.
No, 60.
60.
Oh, 60 or 30.
60.
What was this angle?
30.
This was 30.
So it's 60.
I think it was.
And that little invisible line is really like here.
Right angle,
So I'm
yeah.
trying to complete that right angle, which is 90 degrees.
60.
So this would be 60.
I hope it is.
Okay? So I could use my, well, I got like an adjacent, and I'm trying to find the hypotenuse. Ha! So cosine of 60 equals adjacent 100 over hypotenuse FBC. What's cosine 60? Anybody have that memorized?
Oh,
0.5?
1/2.
1.5? So I believe, folks, sorry, my notes are getting a little all over the place here. But cosine 60 equals 100 over FBC. Because algebra is what it is, I can just switch these two. And FBC is equal to 100 divided by 0.5 FBC 200 newtons. We are almost done. Is that in tension or compression? So it's a little bit tricky with diagonals. Okay, because we don't, it's like, okay, but is it diagonally? So don't even stress about the diagonals. Look at the component forces. Look at the x and the y. What direction are they going? FBCX, what direction is it going? FBCX is going to the right, right? What's FBCY doing? Down. So FBCX is going to the right, FBCY is going down. Down and to the right. So I'm at joint C, I'm down to the right. Am I towards the joint or away from it?
Towards.
I'm towards the joint, which means I'm in compression. Pushing. I'm in compression. which actually makes sense. You're not going to typically have trusses where everything is in tension. So we already had 2 as in tension. I mean, it was a pretty safe bet that one of these is going to be in compression. So yeah, that one's in compression. So tension's pulling in, you got it. Okay? So with that, we're done with this problem. We found out FAC, and we found out it was in tension. We found out FAB, we found out it was in tension, and we solved for FBC, and we found out it was in compression. So now we know everything about all those members. Now when we go to build this thing, we can start to make some decisions. Hey, FBC is the longest beam here. And it's also under the most force, and it's in compressive force. So I'm going to pick materials for that, a thickness, a material, whatever, that's going to support something that's extra long, and in compression, and under the most amount of stress. Right, under the most amount of force. These other ones are in tension. I could replace those with a rope if I wanted to.
Well,
Because they're in tension, right? If I replace this guy with a rope, the whole thing would collapse. Some things work better in tension versus compression. Question?
so basically.